those first three were pretty easy. And then there's D. So D talks about our new, sorry, that's not y of x, that's just y. Our new function being a function over a function, and you know from experience that anytime you've got a rational function like this with a denominator, we're going to have some issues. So let's get to the issues right away. I've set up my table so that I've written my x value in. Guess I didn't put it on my graph, so there's that. -1, -2, -3, those are the ones that are going to matter a little bit more. This caps out at 9, we're good to go. So this line here, we're on page 268 in your book if you want to follow along. This line, f of x, is actually, if I were to write it out, it would be y equals x. It's just 1 and 1, 2 and 2. And this one you can see is an upside down but perfect parabola, in which case it would be negative x squared. So that's just kind of fun that at this point in time we should be able to recognize patterns like this. When they just give us g of x and f of x, we can be like, I know what that one is. And it kind of just helps us get our mind around it. Now, when it asks us to combine these two functions in this way, then we write out our points, our y values for these x values, for f of x, which is color-coded green, and g of x, which is the blue one. And then we're going to divide them. So it says divide f of x divided by g of x. So I'm going to take my handy-dandy calculator, and I'm going to, oh wait, this is a bit of a problem. Let's skip the problem for now. Why is it a problem? Because if I go 3 divided by 0, I get error. Why is that? Because I can't divide 3 into 0 groups. We already went over that. We're looking for an asymptote there, aren't we? Because we've got a denominator of 0. Can't have that. Got to set up some boundaries. In fact, before we move on here, why don't we just put in those non-permissible values? So, at -3, I'm going to draw a little vertical line that says don't go there. Because x is -3, I can't have a value for y. Because 3 divided by 0 is not a thing. And if I put my little points in on the other side here, sorry that they're not super well spaced, but it's a sketch. And I'm going to put my little no-go line there. So I can see even, well, we'll just leave it at that. All right. No values for -3. Oops. And no values for 3, because 3 divided by 0, 3 divided by 0 is not going to work. So we can set those up right away. We have asymptotes. Now we get to the business of graphing the rest of it. So 2 divided by 5, well, 2 divided by 5 is 2/5, so 0.4. So at -2, I can go to 0.4, and I really should be putting my ticks in there so that I can kind of map this a little bit better. All right, so -2, 2 divided by 5 is 0.4. So I'm going to go approximately there, right? -1, 1 divided by 8, I put that in my calculator. 1 divided by 8 gives me 0.125. So 0.125 is going to be really close to this line. 0 divided by no one cares. It's 0 divided by something, so it's 0, which means that this is going to hit this point. And because the numbers reverse their pattern here, I can fill in the rest of these as well. And because I know from previous study what happens at asymptotes, I can go, you know what, I've got this happening, so I know this is going to happen. Got this happening, so I know that's going to happen. And then I could even take my knowledge of asymptotes a little further, and it looks like I've got an asymptote here. And in fact, if I looked at my function, we're cheating here, but if we looked at our function, f of x is x, and this one's negative x squared, the x over x squared, we know that we have an asymptote at y equals 0. So that's just a little bit of extra that we can put in because we have that previous knowledge. That won't work for every question, but we know that it's not going to hit this line. So you can see that the end behavior is going up infinitely here, so this one's going to be going this way and out. This one's going to be going this way and out. And that's just because of the asymptote behavior that we learned about in a previous chapter. So there we go. We've got our graph. If you don't believe me, you can always throw in negative 3.01 into that formula and see what you can do. But again, the other way you could do it is to look at negative 4. X equals negative 4, and figure the values out for f of x and g of x and work that out. So we could try that. I'm just going to do an extra column here. So if I look on the, I'm just going to look on the graph in your book because it's much more accurate than mine. At negative 4, oh, look at that. I've got this value going way freaking down. So I'm not going to get a value for that. I'm going to have a really negative number. So I'm going to go negative infinity. It's a big number. Oops, that's for g of x. See, you got to be careful which ones you put where. So for g of x, the blue one, it's negative infinity for negative 4. It's way, way down. And for f of x at negative 4, it's 4. So then I'm going to go 4 divided by negative infinity. So I can grab just a really big number, if you like. And I can go 4 divided by negative, let's say, 1,000. And it's negative 0.004. So you can see that it's going to be the y value here is really close to 0, but it's a negative, and it's just going to keep going out here and be super, super close to that line. So when we put 4 divided by a negative, a really big number, we got an answer that was almost 0, but just below, which is what we see the end behavior doing here. So that proves that we drew our line on the correct part of the asymptote, proves the graph, we're all good to go.